athletes. Whoop, whoop. All right, it's time to get into this. So for 11.1, our learning target today is I will identify and use different kinds of angles. I will identify and use different kinds of angles. By the way, the symbol for angles, I think we've talked about it before, but is this. It's almost like a greater than or equal sign, except the point's a little more lower down. And so, just so you know, that's a symbol I'll be using for angles from now on. But without further ado, why don't you guys go ahead and work on the warm-up. Pause this video because I'm going to get going on it pretty quick. Okay, I'm assuming you've got it all done. We're just going to add these together because it's negative becoming more negative. So I'm going to add this right down here, 1.5. Remember to line up those decimals. And so you get a 1, 1, so 7.1. Perfect. These two become addition. So it's really, now keep in mind, the negative is bigger. So I'm going to turn this into a subtraction problem, but I'm going to know that it's going to end up negative. So I'm really going to be, I'm going to have 2.6 down here, 2.6, boom. And I know it's going to be a negative answer because it's more negative than not, but let's see. That is 0, 5 minus 0 is 5. Got to borrow 12, make that a 5. That's 6, put my decimal point, 5 minus 2 is 3, boom. Just remember how to do that good stuff. And common denominator is the name of the game, which is 20. So to do that, I'm going to do this times 5, right? Which is going to get me, what? Negative 15 over 20. And then times 2, minus 2 over 20. So this equals negative 17 over 20. How about that? And then common denominator here is going to be 14, so times 2, and then times 7 over here. So we're going to end up with 4 14ths. I'm just going to write over one denominator, because they're both 4 14ths. They're both 14ths. Minus 7 14ths. So that's going to equal negative 3 14ths. Boom. Get them fraction skills. Just keep on her rolling. All right. Time to get on to some vocab today. I should show that to you. Look at it, love it, enjoy it, embrace it, pause it if you need to, going on. Let's take a look at our vocab and let's get rid of that. That's just in the way. Boosh. And all we need is congruent angles and angle bisectors. You'll see the rest later. So congruent angles are two angles that have the same measure, and angle bisectors are a ray or segment that divides an angle into two congruent angles. So just like a segment bisector, right? Except it's bisected an angle instead of a segment. Pause this, write it down, we're moving on, ready, set, go. Okay, so when I look at this right here, I want to label some things right here. So we have a line here, right? And we would call this, I can call this a lot of different things. This could be line DC, right? I'm going to put arrows on both ends to denote a line. We could call this line AB. And we could really keep going. Line BA, I mean, we could call line BC. We could keep going on this. There's lots of choices here. But I want to talk about now a ray, okay? Specifically, we're going to talk about rays today. And how we label a ray is if I'm going to label ray AB, I would label it like this. And this is a ray with endpoint A. I know it's endpoint A. See, in a line, order doesn't matter, right? I could have written line BA, same thing. Same line. Line CD, same thing as DC. But in array, order matters. Whatever first letter you put is the endpoint. And then the next letter tells you what direction. So this is a ray going this way. That means this is a line or array, has one endpoint and then one end that goes off forever. So again, if I were to put ray BA, that is a totally different ray. This is a ray with an endpoint that starts at B and goes this direction. Now some of you may go, but you drew the ray that way. Yes, you always draw with one arrow on the right side. That's just the notation we do in math for ray. It tells us it's a ray. But the order of the letters tells you what direction it's going in. So notice, we have one ray going to the right, right? That's our AB. It's going to the right. And then we have another one that's going to the left. That's our ray BA. So AB is going in the same direction as ray AC, right? We have AC also. Those are going in the same direction. But ray BA and ray BC, right? Because BC is going this way, BA is going this way. Those are two rays. They have a common endpoint. They both start with B, but they're going in the opposite direction. So they're opposite rays. And that's our little crash course on rays. A ray is like a one-sided line. It has an endpoint, but then the other side is going off forever. All right. So now I want to look at this little diagram down here, and we're going to take this right here, and this is angle A. Okay? And angle A has a vertex, so the vertex of that angle is at A as well. Okay? Angle A can also be labeled it can be labeled angle DAB. Why? Because it goes DAB. That's describing the angle. It could also be labeled angle DAC. Again, following it through, DAC. But then again, order doesn't matter on this, so it could also be angle CAD. Or it could be angle bad, angle BAD. Now notice though, what's important is the center. Of the 3 points right here, the center has to be A. Whatever the vertex is has to be in the middle. In other words, I couldn't label this angle ADB. I couldn't go ADB. That's a totally different angle. That would be an angle, if there were a line, that'd be a line going up to here and then down to here, and that would describe the angle created right there. But that line doesn't even exist right now. So you got to make sure the vertex of the angle has to be at the center of the naming, okay, each time. All right. And what else do we know? Angle A is a pair of rays with a common endpoint. Now there's more than one ray I could use for this, but for example, angle A is really made up of, I don't know why I'm writing A, it's AB, ray AB, and ray AD. So notice, what is that? And what is their common endpoint? Remember, the endpoint always goes first, so the common endpoint is A. It's always going to be that vertex, and AB goes this way, and AD goes this direction. And so that is your that's your two rays with a common endpoint. And so what will we say? We say this is side AD. Angle always has two sides, and this would be side of the ray AB, which we already said a second ago, or we could even say the ray AC. That ray would work as well, right? Because AC is still going this direction. Okay? Now, I want to put a couple extra points out here. Let's put the points, I don't know, we'll just kind of place them randomly. We're going to have G, F, and H. I'm going to put some points out here, and they can go randomly. I, J, K. I just put them randomly. The fact that they're on the outside of the angle is what matters. All right? So these groups, these would be considered on the inside of the angle, because angle A is this angle right here, denoted by that arc. So these points right here are called points on the interior. These points that are on the outside are called points on the exterior. And it just helps us to know what points are on the outside or the inside of the angle. If they're inside, they're interior. If they're outside, they're exterior. Okay? All right. So using this information, why don't you take a minute and try to do this example. Look at the figure to the right. Name the vertex of 4, angle 4. So let's look at angle 4. What's the letter that's the vertex right there? That's right. It's U. Name the sides of angle 3. Well, let's see. Angle 3 is right here. So these are the sides of it, which let's name those angles. We have, remember, we got to start with the endpoint or the vertex. So we have ray XW. And we also have ray XU. Those are the sides of angle 3. All right, what is another name for angle XYU? Well, let's find that. We have XYU. What's another name for that? Well, it's this angle, and that angle is labeled angle 2. So we could call it angle 2. Awesome. Okay, I'm going to look at this example right down here. Let me scroll this up so you can see what I'm talking about. And this is 60 degrees. Go ahead and label that. And we're going to talk about congruent angles. And here's what I'm going to tell you. I'm going to tell you that angle QTR, let's see, QTR, that's this angle. And I'm going to tell you is congruent. By the way, see this equal sign with an extra squiggly above it? That means congruent. I think we've talked about that, but I want to make sure and mention it again. And I'm going to tell you it's congruent to angle STR. So they both share a T for a vertex, right? But now we're talking about this angle right here. And since they're congruent, notice I used one arc for this and one arc for this. If they each have one arc, that means they're congruent. If I conversely had angles like this, or I'm drawing these on purpose not to be congruent, I would say like this is one angle, and then for this angle I would use two arcs to show that they're different angles. That's how I do that. Whereas this, they're congruent. We're saying they're congruent, so it's the same angle. But here's what I know. If they're congruent, they have the same measure, which means what can I say? I can say this is 60 degrees as well. So here's what we know. If angle QTR is congruent to angle STR, then both angles equal 60 degrees. And guess what? This makes ray TR an angle bisector. And why can I say that? Well, think about it. If they're both 60, that means this whole angle right here, this whole angle is 120 degrees, right? By the way, notice I use two arcs because it's a different, I'm talking about the combination of them both. It's 120 degrees. And TR is splitting it exactly in half, making it an angle bisector. That's what an angle bisector is and does. All right, we're going to go on the second half of the page. Ready, set, go. Oh, I should just show this for a second. Pause it if you need to, and we're off.